Hello everyone, this is a continuation. This is a part 3 of the series of videos on root locus. So in the previous two videos we have gone through step 1, 2, 3, 4 and 5. So now we will start from step 6. Step 6 is finding intersection of root locus with imaginary axis. So again for that you have to consider the characteristic equation which we had already calculated or computed in the step 5. So I will directly take that equation. S power 4 plus 6s cube plus 11s square plus 6s plus k is equal to 0. So now you construct root array for this. So how root array is constructed? You write all the s terms in the first column in an descending order. That is starting from the highest order moving towards the lowest order. Here it is s power 4, right, is the highest order. So s power 4, s power 3, s power 2, s power 1 and s power 0. So s power 4 means it is an even order term. So write all the even coefficients. That is 1, then s square, it is an even order, so 11, then s power 0, it is an even order, so 1, 11 and k. Similarly, after writing even order coefficients, next you write odd order coefficients. That is s power cube coefficient is 6 and s power 1 coefficient is 6. So 6 and 6. So now how will you fill the s power 2 row? For that you have to consider the previous two rows which are above s power 2 row, that is s power 3 and s power 4. So now how we will write the first element of s power 2 row is you would perform diagonal multiplication here. 6 into 11 it is 66 minus 6 into 1 is 6. So 66 minus 6 is 60 and divide by 6. So 60 by 6 is 10. So you are getting a value of 10. Now similarly, to find the next element, you keep the first column as it is, but you discard the second column and shift to the next column. So now same diagonal multiplication itself, 6 into k, that is 6k. Here there is no term, right? So 0 into 1 is 0. So 6k minus 0 is 6k, and again divide by this term only. 6k by 6 means 6 and 6 will get cancelled and you will get k. Now if you adopt same process for the remaining rows, you will get values like this. So now here we have to check when this particular root array or the system represented by this root array will become marginally stable. So for a system to be marginally stable, a particular row, any row should become completely 0. Here you can observe this row cannot become completely 0 because we can manipulate only the value of k, right? The values which are already there we cannot manipulate it. So even if I substitute k is equal to 0 here, this row will not entirely become 0. Here there is no k term at all. Here if I make this k value as 0, again this row will not entirely become 0. But I have option between s power 1 row and s power 0 row. Here I can make k is equal to 0. Here if I substitute k is equal to 10, then 60 minus again 60 by 10, it will become 0. Now the dilemma is whether I should choose s power 1 row to become completely 0 or s power 0 row to become completely 0. So the solution is very simple. Always consider odd numbered row. Always consider odd ordered row to become completely 0. Here s power 0 is even order, s power 1 is odd order. So you should make s power 1 row to be completely 0. That is 60 minus 6k by 10 is equal to 0. So that means 60 minus 6k is equal to, if you cross multiply you will get 0. Now find the value of k. You will get the value of k as 10. That is, when you substitute k is equal to 10 here, this particular row will become completely 0 and hence system will become marginally stable. So now when system becomes marginally stable, you have to consider auxiliary equation. And how do you consider auxiliary equation? The row which has become 0, the row above that 0 row is considered for auxiliary equation. Here s power 1 row is becoming completely 0. Which is the row which is above the row which has become completely 0? S power 2. So you consider this for auxiliary equation. That is 10 into s square. After s square, what is the next even order? S power naught. S power 0 or naught means 1. So k into s power 0 means k. So 10s square plus k is equal to 0. Again you find out what is s by substituting the value of k. We know that for k is equal to 10, the row is becoming 0. So k is equal to 10. That means we will arrive at 10 s square is equal to minus 10, or s square is equal to minus 1, or s is equal to root of minus 1. But we know that root of minus 1 is nothing but root of I square, that is plus I or minus I. So plus I and minus I are the intersection points on the imaginary axis where root locus intersects the imaginary axis. So now we have our points as plus I and minus I. So now we will again step 7, here it is not applicable because angle of departure and angle of arrival is applicable only if you have complex pole and complex zeros. Again we will solve a problem where we will have complex poles and complex zeros so that we can calculate angle of departure and angle of arrival, but for this particular problem we will skip step 7. So now we will stop our video here. There are two more steps which I will be discussing in the next video.